In this problem, we're told to calculate the acceleration due to gravity on the moon. The moon's radius is 1.74 times 10 to the 6 meters, and its mass is 7.35 times 10 to the 22 kilograms. So let's go ahead and write that down. So we know the radius of the moon is going to be equal to 1.74 times 10 to the 6th meters. And we also know the mass is going to be equal to 7.35 times 10 to the 22 kilograms. So in order to solve this problem, you need to know this general equation. So the force is going to be equal to G times M1 times M2 over R squared. So what we're trying to do is solve this equation, right, for the force of gravity, right? And so this is going to solve for the gravitational force, but you also need to know this formula. So this is going to be the formula of an object if it's far away, right? So the force of gravity on an object that's far away. But if something's close to Earth, you know it's just going to be equal to the mass times the gravity. So just keep that in mind when we're solving this. And so what we're going to do is essentially these solve for the same thing. So we're just going to set them equal to each other. So mg is equal to the gravitational constant times m1 times m2 over r squared. But what you should notice is that m right here is going to be the mass of the object, right? And so what m2 is, it's also the mass of the object, right? So both of these find the mass of the object, right? So in this case, whatever our object is, right, we don't know, it's just like an imaginary object, right, m. So essentially these can cancel. So you just get that g equals the gravitational constant times m1 over r squared. And so essentially we know all these values, and what we're going to do is just plug them in. So in this case, m1 is just going to be the mass, right? So the mass of the moon. So we know what that is. It's going to be 7.35 times 10 to the 22 kilograms, right? So this is going to be the mass of the moon. The gravitational constant, you have to know that's equal to 6.67 times 10 to the minus 11. So that's going to be the gravitational constant. And then they give us the radius of the moon, right? Which is 1.74 times 10 to the 6 meters. So essentially all we got to do is just plug it into our equation. So it's going to be G, which is 6.67 times 10 to the minus 11 times M1, which we know is 7.35 times 10 to the 22 kilograms, right? The mass of the moon, over the radius squared. And so we know the radius is 1.74 times 10 to the 6th meters. And so if you go ahead and solve this, you're going to get that it equals 1.62 meters per second squared. So if you plug this in, this is going to give you the gravitational acceleration, right? Which is what they're trying to find, the acceleration due to gravity. So if you go ahead and do this, you're going to get 1.62 meters per second squared. And that's going to be your answer to this problem. And hopefully you found this useful.